Hi, this is Merlin. Today I'm just gonna talk about Valorant today. The main topic is the B tree. Um, but the B tree is just the data structure to implement the normal binary tree, the limitation of the normal binary tree. But before understanding the B tree, you have to understand the history of this kind of data structure. Um, the first you have to know about this the computer science word, like example, like this the data structure and algorithm is just the result of the or outcome of the abstractions. So what do you mean abstractions? We the engineers, we eventually um we're gonna face a problem, and of course we're gonna fix it. And if it results in some kind of tedious way, we make an abstraction layer or we do some kind of abstraction to fix it. And the I think the best example is in in nowadays a lot of the programming language can we example JavaScript we define how we define the allocation or the assignment the variable assignment also like this const name equals to Merlin, those kind of thing. And those kind of even the variables is kind of really abstractions of kind of storage. Example, if you look at the assembly, there's no such a kind of the variable like that. The we in the assembly like really low level without the even without the operating system, the we used like using the register as a storage. So it's kind of like looks like the variable. So those kind of thing is made engineers some kind of tedious or some kind of into increased more complexity. So we just abstract into better way to it. So and also the data structure is also part of it. Example is stack. Stack is a really popular data structure, right? It's fundamental, and we already know the stack of it. If you look at the x86 architecture, like even 90s, there's no kind of like stack thing. There's no really like stack thing that we imagine. Example, wait, hold on. Like there's no kind of really this kind of stack in x86. In x86 architecture, in the computer architecture, it's just the pointer of it. It's just the pointer, but it just looks like this stack of it. So everything is abstractions, even in the data structure abstraction. So to understand B-tree, we have to understand the history of it. Let me say, yeah, I don't know you are a fan of Pokemon Monster, but let's say you have Pikachu. You wanna store this Pikachu data. Of course, there's gonna be this unique ID of it, and also the age gonna be age or the name. I don't know. The gender is gonna be gender. Whatever stuff is gonna be, or type. Is it electric or like those kind of things? So they're gonna be those kind of things, and there's a lot of Pokemons, and we want to store it into some kind of data rather than we store it like like char. I forget the word of it. Charlie chart. And whatever. Well, I don't know. So rather than we put some kind of data into like this kind of some kind of one way array, like we trying to do another stuff, because if it's like 100 data, it's okay, but if it's like over like 10,000 data, that's gonna be really hard to track, and because you have to find example, if this ID is 0, and this ID is 1, and this ID is 2. But what if we want to find 80 ID? We just have to go to read all of the data till it encounter 80. So that's gonna be really hard. This is gonna be really kind of like unnecessary. So we trying to solve this issue of it. And also this kind of data unit of the Pokemon is called the record. And this kind of ID, this specific ID, the unique thing, we call the key of it. So rather than doing this, we only gather the key of the records. And that's called the index. That's called the index of it. There's no kind of like complex thing, and that's called the index. But this index have a bunch of keys of it. And that's gonna be really hard because if there's a lot of data of it, there are a lot of keys is gonna be more. There's gonna more time to look of it. So now the trick is come from binary tree. Binary tree. If there's a root of here, and let's say it's 2 of it, and the left side is gonna be more. The left side, the node has to be is smaller than the root, example 1, and right side of it is gonna be bigger than the root of the value 3. And example, when you're trying to put it here, we can just use hierarchy thing to search for the specific ID. But the binary tree, the binary tree limitation is, what if there's are more nodes, but there's no parent and there's no child nodes. Example 1 node here. Example like this. Well, those kind of thing is kind of unnecessary, right? Because we can just put this part on here, rather than like going to this kind of long depth of it. Because when you're trying to traverse it, when the height of this kind of tree increases, there's gonna be more time complexity of it. So to solve this issue, we just assume that why don't we just put the nodes, but the that holds a lot of data. Example, if it's like 22, let's put 20 and 21. And based on that, we put the more nodes on there, and that means that we will have the more decreased height of the tree. That means that there's no more bigger time complexity rather than the normal binary tree. And that's where B tree come from. Yes, the B tree data structure, those kind of thing is kind of abstraction way of this kind of history. We find the problem and we know that it's the issue, we try to solve it, and if it's kind of like, if it's like good way, we just trying to make it abstract and easy to use. And that's kind of like B trees come from. Rather than putting in here and rather than putting on the all of the one index, one linear index, just like array, put it like keys here, but we just trying to like think about the best data structure for it. So this is the really thing you have to understand. This is not just the theory. This is not just the books, just the theory just you have to memorize. It's just the kind of history of it. We face a problem and we solve it, and we just repeatedly try to do the abstraction, and we just use this rather than go deeply. That's kind of like history and repeated history of engineering, software engineering thing. So this is it. So have a nice day. See you next time. Bye bye.